Hi Jeff, I've just gone ahead and taken a few minutes to kind of put this on a video. I'll share the link with you so that you don't have to do the testing yourself unless you want to. In this particular case, basically the video is a continuation of the discussion that we were having on the private chat within SQL Server Central. As I mentioned in my post, or as I mentioned in the reply, the reason I used DVCC drop clean buffers was because I wanted to simulate a cold cache, which I'm not sure about you, but I've personally experienced it to be a bit frequent, mainly because inside my data warehouses we end up loading a significant volume of data, and as a result, very large ETLs, usually about 2 hours, 2 GB of data per hour, results in the memory getting flushed out. And as a result, when I start running the query for something like this, there is really no assurance or no guarantee that the data that I'm looking for is already in the buffer pool when I need it. Also, the other thing is that typically I try to create indexes only where that query gets executed very frequently, and it will actually benefit most of the users most of the time. But there are other queries that are not used so frequently, for which we don't usually create indexes because the overhead of creating the index isn't sufficient enough to justify any performance benefit that it might actually give us. So for those reasons, again, the other thing is that, like I mentioned in the post, the original post or the question was about a very large data warehouse where a huge volume of data was being inserted, and that obviously would have resulted in a significant amount of the buffer pool being used for the ETL process as well. Index rebuilds and a ton of other stuff can also happen in the background. So all of these contribute to making it almost certain, or I'd say at least a 50% probability, depending on luck, I'd say more than anything else, that the data that you're looking for may or may not be inside the buffer pool when you need it. So that's the reason for the cold cache example that I gave there. Now, coming back to the more important one that I wanted to actually discuss with you over a call was the fact that I've actually gone ahead and created the example here, and this I've done in the other video as well, but I just wanted to kind of highlight it because I think you probably missed out on that. So I thought that I'd take this moment to kind of really just explain that scenario, right? So the point of the video that I was creating over here is basically to explain this part of it. So as you can see here, this is fairly early on in the discussion where Sergey mentioned that you put a clustered index on the primary key column and non-clustered index on the ref age column, and that's wrong. You're not supposed to do it that way. You're supposed to actually do this, where he says that you should create a non-clustered index on the primary key columns and a clustered index on the ref underscore age column. So that's basically what I wanted to kind of demonstrate here. So in this case, the base table that we have here, let me just go ahead and open that up real quick. So as you can see here, it's the exact same table as before, so you can go ahead and do the same stuff that I just did here. But the idea here is that if you look at my unpartitioned table, I have the ref underscore age clustered index, which is part of the original script that I'd given you, as well as I've got a non-clustered index on a column called ID, which is an integer value of identity column. So if you just look at the table definition, that will kind of clarify that part for you. So I created an ID column to kind of simulate what would be a primary key in this scenario. So let me just go ahead and scroll down here real quick. So it's an identity column, and I just put 1, 1, really nothing else. Once this column was added, I went ahead and created a non-unique, non-clustered index on this one. Now I've also got the same column here in my partition table without any indexes here, as you can see. And if I scroll down, you'll see that I've got the ID integer column here as well. And in this case, if I look at design, you'll see that again it's an identity column. So I'm just trying to make sure that everything is exactly the same, so that there's no discrepancies in the way that we're doing things. So again, we've got identity, and then we got 1, 1, right? So as you can see, the two tables are exactly the same, except for the fact that this one now has an additional non-clustered index on the primary key column, whereas the partition table even now doesn't have any indexes. It's just the partition table as it is. So coming back to the point, so you can see here what he says here is that you need to compare apples to apples. You need to create a non-clustered index on the primary key column, So in this case, I'm just using the ID column to kind of give every row its unique value, and therefore that will be my non-clustered index. And then you can see I've got clustered index on the ref_age column, which is basically the same thing that we were doing before. So this time, instead of using my queries, I've actually used the same queries that you've posted on the forums. So in this case, you'll see that I'm actually just dropping the buffer pool once, and then I've also gone ahead and added statistics for the IO as well over here for both these cases, but the rest of the query is exactly the same as before. So let me just go ahead and execute this, and we'll just have a quick check on the performance of these two. So the first table is basically the partition table, and the second one is the non-partition table. So you can see our unpartitioned versus partition. So when I look at this now, again, I probably should have started off with just the time statistics, but if you look at the time statistics here, you'll see that the first execution definitely took 2.5 seconds, whereas the second and the third and all the remaining executions for the partition table took about 500 milliseconds, so half a second on that side, right? And about 1,100 milliseconds in the CPU time. Now, if you come here to the non-partition table, which is the non-partition table which has the index on its own, the first execution, as you can see here, is half the time as the partition table, right? But the subsequent queries on the cached data, as you can see here, is all in the range of 900 milliseconds. So you'll see in this case, adding the additional indexes degraded the performance of the table despite the suggestion that was given here. So in this case, what's happened here is that after creating the indexes as suggested, it actually degraded the performance of my table, and it actually increased, or it's basically with 2 indexes on that table, my query performance has actually degraded, whereas on the partition table without any indexes, my performance remains about a half of what it would be for the other table. So in this case, as you can see, basically this is a scenario that I just wanted to kind of explain to you, or see if we could come to some kind of understanding in terms of what exactly is going on here, just so that we can both explain this behavior. Now, as you can see here, I'm not flushing the buffer pool, so that happens only one time. But once the data is cached, you'll see that the partitioned tables are actually giving consistent results. Let me just go ahead and do this as set statistics IO off, because we don't need all this information here at the moment. So let me just go ahead and do this as well. So this goes here. Great. So now that this is executed, you can see that this is the partition table. Buffers are dropped only once, and then we've got the first execution obviously takes time, that's pretty much understood, but the remaining executions are at 600 milliseconds approximately. Whereas for the non-partition table that now has a clustered index as well as a non-clustered index, you'll see that the execution times are hovering close to about 800-900 milliseconds, which is about 300 milliseconds more than what it is for the partition table. And other important thing that I just want to kind of show you here is that the CPU time for the partition tables is about half of what it is for the indexed columns, as you can see here, for the indexed query that we're using at this point. I'll just quickly go ahead and show you the execution plan as well over here. So I'll just go ahead and do the actual execution plan. Great. So you can see here that I've just got a very basic table scan with a 93% overhead on just reading the data from the underlying table itself, and then I've got a hash match partial aggregate of 7%, and that's pretty much the bulk of everything that we're doing here. Now I just wanted to kind of show you this because this changes significantly when we do the other query. In the other query, you'll see that the index scan is 70%, but a significant amount of time is spent doing the hash match aggregate for the 29 for the ref_age column. So as you can see here, that basically I'm just doing I'm not trying to prove anything, I'm not trying to act smart whatever it may be. I'm just showing what I am noticing in my data. And the fact here is that I've got an unpartitioned table over here, which is performing about half as slow, or it's performing at 600 versus 900 for the table that's got 2 indexes, right? And even then the CPU time is significantly better, because you'll see that the CPU time is about half, or even less than half actually, compared to what we have for the indexed column. Oops, sorry, just a second, I should have unchecked this. So I've got 640 milliseconds, 619, 702 milliseconds, whereas this one consistently always hovers close to about 1 second, in spite of the fact that the data is in the cache. Right, so this is the non-partition table, actually, the one that we have here. So that's pretty much what I wanted to show you, and I can definitely agree with you on a few points here, that yeah, I am a clown most of the time, and frankly I don't have a problem with it, and I'm wrong quite frequently. I don't have a problem with that either, as long as I ultimately learn something useful out of it. So this is what I'm seeing at the moment, and I'd really appreciate if someone can explain to me what I'm doing wrong here, or basically just where this takes us, basically, in terms of what does this mean in the scope of the discussion that we are having, right? I don't want to publish this online. I'm not really interested in getting anything out there in the open, so it's more about my own self-learning at this point, rather than trying to prove I'm right or anything of that sort. But I hope this kind of at least conveys my point of view in terms of what I'm seeing. I'm sure there's a ton of differences, and I'm sure that when you run it you might see something totally different, but I would really like to get to the root of this and try to understand what's going on here. And as you can see, this is again just a very basic example of a table that has 2 indexes and is not performing faster than a partition table, and at this point I really don't know what else to say. So I'd really appreciate it if you could take a minute to kind of let me know what's going on here. Thanks, Jeff, and I hope you have a nice day.